Hi, I'm Brooklyn Aviles, and this is my Physics 2211 Lab 2 projectile motion. In order to do the lab, we first need to understand the fundamental physics principles behind it. This includes the momentum principle, or Newton's second law. The force of an object is equal to the change in its momentum. This can be arranged to solve for the position update and the velocity update equations, which will be used in our Glowscript code. We also have drag, or air resistance, a force that opposes the direction of motion with a magnitude that is proportional to the speed of the object squared. This equation can be seen in the bottom right. The purpose of the lab is to see how the momentum principle can be applied to situations where the net force is not equal to zero, like in projectile motion. We will use Glowscript code to model the motion of the object to see how it moves when there is a non-zero force acting on the ball. From the experiment, we can see that our object moves in a parabolic fashion. We can rearrange the momentum update equation to solve for the initial velocities in the x and y directions, using the distance that it traveled and the time it took to complete. Additionally, we can see that the velocity of the object in the x stays the same, so there is no net force acting on the object in that direction. Additionally, we can see that the velocity in the y direction is changing, so there is a net force acting in the y, which we can apply to the momentum update equation. I define the system as the ball and the surroundings as the earth. Without drag, the only force acting on the object is the weight force, and with drag, there is a drag force that opposes the motion, and there is the force of gravity. Vix was solved for by taking the average of the distance over the total time, using the position update equation, and Viy was solved for by finding the time at the maximum height and multiplying it by F net over m, or gravity, which was solved for by using the velocity update equation. For the experiment, we took a crumpled piece of paper and threw it with an initial velocity shown in the code snippet. The ball was thrown in the positive x, and we used a tracker to track the motion of the object in the parabola. Additionally, we used the motion of the ball to find the initial velocity to put into Glowscript. Here is our tracker video, and on the right you can see the motion that it followed through the video. The dark green box solves for the drag force. This updates the drag force depending on the speed of the ball at the given time. The light green box shows our position update and velocity update equations. We used F net calculated using Fg and F drag, and if drag was equal to 0, the only force acting on it was Fg. We then solve for the new velocity at each time interval to then use that velocity in the position update formula. Here we can see our Glowscript results, where the no drag has a flat velocity at Vx versus time, and we can see that with the drag that the velocity is no longer constant. We can see that it is now changing in the negative x direction. Additionally, we can see that the y versus x graph on the very right, we can see that with drag, the height and the distance is no longer as great as it was without drag. We can see that the tracker graph shows a parabolic curve, but it is much taller than the Glowscript code. Additionally, we can see that when the drag force is included in our calculations, that it does make an impact to the motion. We can see that initially the drag and no drag are the same, but as time goes on they deviate, with the drag graph not reaching as high as the peak and hitting the ground sooner than the model without any drag. For sources of error, I took a bad video. I took the video and then realized that my projectile is much closer to the camera than to the cabinet, so it's making the projectile look like it's going higher and farther than what it is most likely going, just because my dimensions are off. Additionally, I don't know how to calculate drag, so my drag force is probably wrong, but at least it is following the same trends that drag would actually cause the error or the graph to have. Does the object experience terminal velocity? No, it does not. The ball would have to be falling way faster and for much longer for it to be able to reach the point where the drag force is equal to the gravitational force. And for who will reach the ground first, a ball thrown straight up or a ball thrown at an angle, we can see using the velocity update equation that the object thrown at an angle will reach the ground first. This is because for t total, the time is equal to 2 v initial over g. And when we are throwing the ball at an angle, our y direction is going to be smaller, causing our time to be smaller because there is less velocity, or like the velocity will be smaller because we have to account for the angle. In conclusion, we can see that our object does model the momentum principle when there is a net zero force.